Hello everyone, I'm back again. Welcome to TestFlix 2023. I'm glad to see you all as a part of this great initiative from the Test Tribe. Thank you for giving me your precious time in hearing my experiences and the challenges as a part of a test engineer when I was in large enterprise organizations. Well, it wouldn't be an exaggeration to say practices and fanciful things that you get to see in large enterprise organization, you won't get to see anywhere else in the world. So this talk makes it all the more interesting and fun to take a ride along with me for the next 15 minutes. I think it's a good time that we dive and know my four main unique experiences that I had when I was part of a large enterprise organization. So it's time that I start with my first unique experience. Networking is the oil. Maneuvering yourself in a large enterprise organization need a meticulous planning and a calculated move on day-to-day basis. Technical skills can surely help you keep afloat and deliver your tasks more efficiently. Knowing people and networking will take you a very long way. 2009 was my first one-on-one with my manager, and he gave me the first tip, which I can never forget even for today. He said, "Sono, you're great. Your technical skills are great as well, and you're learning good. But if you do not have people behind you, the technical skills only take you to a certain level, and beyond that, you'll be frozen if you don't have enough people backing with you. So start investing in knowing people, keeping them as your allies, and grow your network." It is so important, and his words still rings a bell in my ear. So networking is just not about the team that you're working with or some scrum teams where you're associated with. It should go beyond your particular role and function. As a test engineer, for you, the information is the key. That's the currency which you're going to trade. Be it your promotion, be it your testing, influencing for a bug fixing, or having to influence for the prioritization with your product owners, or even for the time when you may have to do a cross-functional switches. Networking definitely going to help you. So keep this in mind. Invest time in meeting people, getting to know them personally and also professionally. Understand what goes into their role. Be curious to understand the challenges that they may have to face. Maybe when the day comes, you have enough information to take the decision. So now it's time to move on to my second experience, learning on a slow burner. Steady and unrushed are the main characteristic of a large enterprise organization. Like I already mentioned, there are several functions involved to make a company grow. In large enterprise organization, every role is broken down to its core. For example, in a test engineering, there are separate unique test engineers associated with a scrum team to perform only testing on the newly built features. And the further to this, an end-to-end testing with test automation, maintenance of a healthy pipeline, etc., is to be performed by the regression testers, which is a bunch of testers sitting apart somewhere. And then there is subject matter experts like accessibility testers, translation testers, security testing, performance testing, data governance and laws. And there is a center of excellence built for each of these roles. As a test engineer, if you have to grab these learnings and skills, you have to really stay long with the company, invest time in learning every role at its core, and do moving on to the next cross-functional role. And it takes a good amount of time to call yourself as a full stack QA, maybe, where you can confidently say, I know several other types of testing because I have been part of the center of excellence, to jump from one to another. So here, the first learning that you have to get is learning is slow. It's a farming technique. You have to plow the land, sow your seeds, water it, wait for the right time for it to grow before you can cut. Learning is slow, but you have to hang around to reap the benefits. Let's look at my third unique experience. Quality Sherpa, Quality Patrol, Data Specialist. Have you heard of these roles outside anywhere? You may not have. Large organization is also very famously known for their fancy roles and names and titles. So you may not be surprised if you get to hear a very unique role from somebody who's working in a large enterprise organization. Sometimes these roles are made to look larger than life, simply because these roles are given some additional powers of asking questions, or maybe to follow up or send emails, which make it look so important. But in outside market, these roles are seen as a small task as a part of a large function. So be very careful. If you're a test engineer, part of a large organization, you see such fancy roles, it's good within that ecosystem. But by and large, if you want to establish yourself confidently for the wider market to be absorbed at any point in time, then you can't sustain in this role. Take a very meticulous and calculated decisions when you do the cross-functional shifts. So for example, let me say Quality Sherpa was a person who used to pick up the reports at the end of every sprint. He or she used to make sure that the KPIs are met, the dashboards are updated, a follow-up mail is is sent, and that is all the job they used to do. But if you want to recognize yourself as a quality engineer, doing such role may not add much of a value on your resume. So here's my word that please do not be attracted to these roles. Be curious to know what goes behind these roles. Pick up these as a part of a short-term initiative and then move on to something more mainstream. But do not get established in this role too deep. The another downside of these fancy roles is they don't have any career growth or the place to be at. At some point, you see yourself being stuck in this abyss, not moving anywhere. So be very careful when you pick up the roles and do a thorough analysis of how this fits in the wider market and how this role is seen and what are its probabilities of career growth. It's very important. Time to move to the next unique experience that I had, which is the quality audits. Quality audits, in my perspective, is a complete sham, not required at all. But still, many large enterprise organizations feel it's necessary, and I can't blame them. You know why? Because the whole organization is built on such a complex matrix and structure with so many people involved. There is no innovative way of finding the progress or any other way of finding the quality of the development that's happening, and they land up finding this quality audits. And this is a borrowed concept from the manufacturing domain, by the way. So an auditor's job is to come up with the KPIs or the metrics that matters, which according to them matters, and which can describe the quality of this application that is being built. It may be number of test cases, type of bugs reported, number of high, number of low, when something was closed, when something was opened, how many production bugs, the coverage of your test cases as a part of your traceability, automation coverage, pipeline health. It can be various KPIs and metrics depending on the team, the application, the type of business you're dealing with. In my experience, the first year was a very terrifying experience. I actually was very frightened. My legs were shivering when I received a mail that there will be a quality audit happening, which was complete surprise as no one had let me know that there is this ritual that they do at the end of the year. And I was running around floors to floors, meeting my friends, trying to ask and trying to learn how these reports are taken, what matters to them, what are these KPI metrics, and how is this I'm not aware, and things like that. I somehow got through that phase. And then for the next 6 months, I took time in understanding the entire process. Networking did help me there. So I reached out to the people, especially my seniors, trying to understand what this whole ritual is about, what goes behind this custom, what KPIs matters, and what are the systems that is involved where these numbers are pulled out from. Slowly, I started to realize it's not so inaccessible. It can be changed. Just a command line code, just to tweak in some things, and then you will be able to generate the report the way they want. You're happy, they're happy. So my second year quality audit was like a smooth sail. I was riding high tides without any fear. So you see, if you're a part of a new organization where there are some quality audits, all you have to do is reach out to the right people, get to know the system where these data are pulled, and master the art of tweaking the data. Is it a good practice? No. However, quality audits and the way it's practiced is also not so reliable enough. These are the processes that we have to live with and support because we are part of that organization. Take it with a little pinch of salt. I wish I can go on with my unique experiences on and on and on. However, keeping the time in mind, we may have to move on to the next section, which are the challenges. It shouldn't come as a surprise, which is the custom tools. Large enterprise organizations are very well known for having some in-house custom development to support their internal processes, be it the bug management tool, test management tool, or the test cases design, test automation, usability testing, be it any of these, we see a lot of custom happening. So there is a team, there are tools to have internal stakeholder like us to make use of these to fit with the entire ecosystem, and you don't have to worry about some integration scenarios or about creating a test data, because they would have considered all these things in mind when they design the framework. When you try and build from an external framework, it is highly discouraged. And even if there is an external tool being used, it's usually a licensed one, considering the security and other aspects of the organizations. Now, working on a custom tool is great, but I wouldn't recommend to keep focusing only on that. If you're working on a custom tool or an internal tool in your organization, spend your personal time in learning what is happening out there in the market. Reach out to your friends and industry peers outside your organization to know what tools and frameworks they are using, what are the processes they are following. Meetups, conferences are a great places to exchange such information. It is important that you're well aware of the current trends and practices outside your organization. You feel more confident in case of any unexpected situation. So build this confidence ground up. Keep updating yourself, especially from a process and tooling perspective, and also the frameworks perspective, so that you don't miss out on the present needs. All righty, let's move on to the second challenge, which is keeping up with the legacy. No matter which corner of the application will be put into or you will choose to go, you will bump into legacy code sooner or later. Any enhancement, feature development, new features, strategic initiatives, name it any fancy name, legacy code is there to haunt you. Something that is built for 30, 40 years, keeping up their revenue and customers happy cannot be changed in a year or two. And it's going to linger around for a long time. So, legacy code you have to make peace with, especially test engineers. It's a challenge when you have to integrate two different worlds, one which is extremely modern with the new technologies and one which has been built everything ground up decades ago. You have to identify those areas which cannot be automated and hand it over to the teams which can provide support or make a case to have an additional resources to help you test these things on a day-to-day basis. If you are facing a major challenge in test data management or creating the test data to support your end-to-end flows, you have to identify the most plausible way and the most important risk related areas which needs a special attention and start working on the strategies of how this can be achieved, either by testing by yourself or you have to leverage the technology making use of test automation and do it. Most likely, sticking to my previous slide, which is a custom tool, these tools usually will take care of these situations, but most likely there is a reason that it can also be missed. Making a case for the internal tool development team and letting them know your team's needs and requirements can also be a good start. So when you have to work with the legacy, you just can't escape. It's a Halloween, which is gonna stay. So are you ready to hear my third challenge, which is the web of systems? There are variety of systems and environments which will be spinned up for various reasons and purposes. One of the major reasons that I have heard is also about testing an application in different configurations. So this poses a great challenge for test engineers who are involved, even if it is for a Scrum test engineer who has to test this newly built feature across different configurations, across different interoperability features. And then you have many systems to keep tracking about. Let's not forget the quality audit I just mentioned, where there are various KPIs and metrics being built and spinned around these many test environments. It just runs crazy. Sometimes you find yourself doing the same task all over again, and that's exactly what drowns the motivation of test engineers because at the end of the day, they feel they're learning nothing. So, in these cases, the best way is to have a conversations with your manager and especially the line manager to establish what is your unique expectations from your role. What would you keep as a prior one and what would you keep as a prior two? Setting a very clear expectation and a common understanding lifts away the burden of doing something which you don't want to. And maybe, like I already mentioned, large organization will always have a resources to fill in and somebody can step up to do some other role while you can invest your time in something that interests you the more. All that it needs is a communication. So don't fear, open up, but even before you do the communication, first do an introspection to realize what is it you are expecting from this role to learn and how long you want to do this. By setting up the expectation for yourself, you'll be able to do a very clear communication with your line managers and build your goals against it. Otherwise, you feel yourself doing the same routine task without anything new. And that's not so nice to have, isn't it? So let's move on to our fourth challenge, measuring everything. The obsession of measuring everything is just runs insane in these large enterprise organizations. Like I already mentioned, there has not been any other innovative way of measuring how something is working. We always fall back to the traditional methods of numbering and quantifying everything, including the happiness or the user experience quotient of it. And it runs too deep in layers in large organizations. I have not seen this obsession in the small or medium sized organizations. Well, in the conversation, it comes and goes, but not to a point that we look at every number, every sprint, in every sales report, and things like that. So this obsession runs too deep, and it's a part of the DNA in the large enterprise organizations. So you have to familiarize yourself that if you're a part of a team in large organization, you have to move around and maneuver with the numbers, learn to quantify things, be innovative, or be in a position of suggesting innovative solutions for these things. Can I change the course of action? Not really. Remember the quality auditors I mentioned? Somebody sitting across geography making their own KPIs and metrics and rules and guardrails. You just have to follow. You're one other person in the organization who has to follow this entire the structure and the guardrail that's been defined. Can you get away from it? For sure if you leave the company, but I highly do not recommend it. These are small parts of the organization which is there, and the main idea of sharing these details is let you know that these things exist. It's a part of the culture and it's a part of the company, which not much can be changed from the position where you are. If you're a test engineer, a quality engineer, a performance test engineer, or even maybe a QA engineer or a QA manager, because these decisions are taken at a very high levels. And unless you are in a very influential position, things cannot be changed. Having said that, here is my last slide. Thank you so much for your time listening to me.
Hey everyone, welcome to TestFlix 2023. I'm Akshay this side, and in this session, I'm going to talk about blending automated testing processes with deployment in GitLab. So to start with, let's understand a bit about GitLab. So this is from the About GitLab section of the GitLab official website, which states that it is essentially a DevOps platform. So other examples of such a platform include Jenkins, GoCD, TeamCD, etc., to name a few. In Gojek, we use GitLab mostly for our testing and deployment processes in our CI/CD processes. So before we get into the details of the topic, let's try to understand a bit about the problem statement. So what happens is in a conventional QA automation process, usually the tests reside in a project which is different than the application repository or the service repository which is under test. What this means is that when the QAs or the SDETs, when they design pipelines, usually they end up doing that in a standalone fashion, meaning that there is a separate or a standalone pipeline that runs the tests in an asynchronous manner, usually in the nightly or scheduled builds. Now, this comes with a few problems. For example, it makes it difficult to pinpoint the test failures and then attribute them to the specific changes that are going into the application, right? Because what happens is, consider this example where uh, the application development is happening for a day. There are 5 or 6 or 7 changes going into it, and then the tests run in that nightly or the scheduled build, and then the next day you see some failures, but then you don't know which of the 5, 6, or 7 changes have caused the failure. So as such, it becomes difficult to pinpoint the test failure. Moreover, it might not be optimal usage of the CI resources because you're running the job separately and not with the application side changes, right? So in this slide, I've tried to put screenshots of how the pipelines usually look like. So the pipeline one is the application side pipeline, which typically has like a few linting checks, unit tests, etc. And then it gets built and gets deployed to integration, right? And let's say then there is a separate functional testing pipeline which runs in a standalone schedule separately, right? So yeah, so that's about the problem. But then how do we address this problem? So one of the ways to go about this problem is using a multi-project CI setup, right? So such a strategy will allow us to combine two different pipelines into a single multi-project pipeline, right? So in this slide, in this animation, you can see that there are two different pipelines that have been combined to look like a single pipeline, right? So the application pipeline, which becomes like an upstream pipeline, and the test pipeline becomes like a downstream pipeline, right? So you can see that the tests are now running along with the application side changes. There is no standalone pipeline which is running separately, right? So this is sort of a crux of the solution, right? But then how do we implement this in GitLab? But then even before we go into the implementation details, I would like to stress on the fact that GitLab is just an example to show how it can be achieved. This can, of course, be achieved in most of the modern CI tooling systems like Jenkins, GoCD, and TeamCity that I named earlier, right? What's important here is the strategy that we are using, right? So in this slide, I'm going to talk about the implementation part using the trigger keyword. So the trigger keyword in GitLab is essentially the crux of this whole session, which sort of explains how to combine two different pipelines. So as you can see here, there are two different code snippets, which are nothing but two different pipeline configurations following the GitLab YAML syntax. On the left side, it's an application project, which forms an upstream pipeline for us. And on the right side, you can see that it's a test project that forms the downstream pipeline config for us. In the application project pipeline, you can see that there are a few stages defined. We'll be focusing on the testing stage because we want to talk about combining the testing part in the application side pipeline. So as you can see, it is attached to the stage functional test, which is declared here. And then there are a bunch of variables, which I'm going to talk about in the later part of the slide. Uh, there are also a few other parameters. And here is the main part, which is the trigger keyword declaration that forms like a bridge between these two pipelines, right? On the right side, we can see that all the details of the testing job are declared here. It's all declarative syntax in YAML, so fairly easy to understand. So you can see that run my awesome test is basically a downstream job which defines what should be done as a part of this testing job in this pipeline. So you can see that other than the script part, which is basically which will have the key steps to execute the test. In your case, it could be anything. It could be a Maven command or it could be a Gradle command
मतलब क्या
to
चासी
invoke the
चासी
test.
बंधन है उसको तो एक
But the important part here
पैराग्राफ
is the
बोल ही
rules,
नहीं पा रही है, मतलब
which
मुंह से
say
नहीं निकल
there
पा
are a
रही
bunch of rules here
बेटा ये
which are
वो
containing a few variable
पता नहीं
checks.
इतना छोटा सा
So you can
चीज
see that we
बोल
want
पा रही है
to ensure that this gets
मैं ये
triggered
कर
only
पा
when the
वो कर
CI
रही
pipeline source,
ऐसे ऐसे बोलते
CI
जाइए
pipeline
एक
source
छोटा
has
सा
a value
पैराग्राफ एक
pipeline
गोल ही नहीं
and the
डिसाइड है
upstream project
हाँ
ID
और दिन में मेरे
has
को
a
यही तो
certain
पढ़ना है
value.
उससे
So you can see
बोलते रहेगी
that
वो
application project one code, right, which is declared here 399941. So that is combined here. And we are comparing that with the value of upstream project ID, which is coming from here. So this is where the variables which we talked about earlier are coming into picture. You can see that I'm populating the default values of some of the predefined variables defined on the right side to some of the new variables that I need to pass in the downstream, right? Now, why we are doing this copy is because the predefined values or the variables which are coming here will have different values for this project and this project, right? So what we are doing is we are essentially copying the values of application side project into different variables, which can be seen here. And then in the test pipeline configuration, we are using that for our rules. Uh, and then you can have multiple jobs for running different suites. So you can have different set of rules to satisfy that so that this job gets attached in the downstream pipeline using these conditions, right? So let's get back to the important part of this session, which is the trigger keyword, right? So in this trigger keyword declaration, I am specifying that the project should be GitLab CI test project, which is basically this project. And then I want to target the main branch of that project because then it's also possible to override this value and sort of have any custom branch to target on the test project, right? right? This means that now there is no need to have a different standalone schedule or a different pipeline where you might need to do automated or manual triggers separately, right? So such a setup will make it easy to understand the failures on a per change basis, thereby leading us to uh, segregate and track, debug, and fix the test failures for each change that is going into the application or the service under test, right? It is also possible to pass the parameters like I mentioned in the previous slides, right? We were passing a few predefined CI variables from upstream to downstream, right? So these could be actually useful in sending readable and easy to understand Slack alerts or email alerts with the specifics of each job. In this slide, I've tried to put a screenshot of how the alerts look like for us, right? So here you can see that at the top, it states the result for what is the test job name and the job ID, which is coming from the GitLab variables, right? Test group is something that we passed again from upstream. Uh, it's called my test tag here. And then there are a bunch of other things like who was the pipeline triggered by, right? And on which branch of the application project, right? We are also logging extra details like what is the branch on the downstream pipeline and what is the name of the downstream pipeline project, right? And a few other testing statistics which are seen here. As you can see, it is very intuitive and it makes it very easy to debug the test failures on a per change basis. As there are also extra links for going to the GitLab job or the pipeline itself and the report portal logs as well, right? So this is a bit of a Slack integration that we have tried to put into our test framework, which makes the whole thing possible end to end, right? So that's pretty much it about the topic itself. I hope this was useful. But again, I would like to stress on the fact that GitLab is just an example here. This should be possible pretty much with any modern CI/CD tool which is available in the market, right? So to conclude, I'm also putting a link to the blog where this topic is discussed more in details with some more examples. I hope this session was useful to you, and I also hope that you get to implement something similar in your project for your teams. And if you encounter any problems, I'm happy to discuss this more. Feel free to reach out to me on LinkedIn and have a fun time at TestFlix 2023.
Hello everyone, my name is Kat Kwiatek. I work as a quality engineer at Zoopla. I look after pipelines, health of the application. I try to write maintainable code and follow programming good practices. Today, my atomic talk will be about linter DIY. We'll be talking about what is linter and what it actually does under the hood. So what is linter? Linter is a tool that you install in your project that does static code analysis, means that checks the code without actually executing it. And linter can detect potential issues with syntax errors, code style formatting issues, security issues, performance concerns. Some of the IDEs have it already built in, like Visual Studio or IntelliJ, but you can also install it as a separate dependency. So why to use it? It's mostly for the consistency for the application code, test code. So imagine that you have 4 test engineers working on the same framework. Each comes from the different backgrounds and is used for different styling in their code. Some of them add semicolon at the end. Some of them use double quotes or single quotes. You want to enforce consistency without never-ending PR reviews. Remember to rename this variable, remember to add semicolon, and so on, so on. So you want the configuration for such issues to be configured in one place and probably defined when you start the project. So everyone who joins joins your team can follow the same set of rules. So linter improves readability of the code, maintainability, but also fewer bugs get to production as a result of it. In the test framework, less flaky tests gets to the environments. So here is example output of the linter. I run it on my Playwright test framework. As you can see, some of the issues highlighted by linter are errors. Some of them are warnings. Some of them are around the styling issues, like double quotes, single quotes, or missing semicolon. And I'm using also ESLint plugin for Playwright tests. So that one will highlight wherever I miss a wait in some places, or I maybe do the hard-coded page wait for timeout where I shouldn't, when it's not the Playwright good practice. So here's the output of the issues that has been found in my code, and I can fix them now. There are a few considerations when you work with linter. So linter will be highlighting issues as you type. Imagine that you are in a momentum, you want to finish this block of code, you know how to make it work, but there are those distractions, context switching, errors, highlights, red and yellow underscores everywhere. But you can configure linter to highlight those issues when you save the file, when you finish typing, or before you commit. As a pre-commit hook, the linter can check your code before you commit it actually to branch. We can be ignoring rules. So sometimes there is a situation that there's no other way. You need to use this page wait for timeout in the Playwright test. So you can instruct a linter to skip this line from the code analysis check, or you can exclude the whole file. But in a situation when you skip the same rule in many places in your application, you may just skip it in a config as well. Or maybe you can discuss with your team what's the best approach here. Maybe we shouldn't be skipping this rule. Maybe there is a better way of handling the situation. Linter can be showing false positive errors. Maybe like that there are not really real errors, and you will learn to avoid them. You'll be forcing push to the branch. That's not the best practice. And something to consider, you listen to this presentation now and you think that, oh, I really want to add linter to my application, to my test framework. That would be great. Keep in mind, adding linter to mature project involves lots of refactoring, renaming variables, fixing styling issues, and so on. Make sure that you have sufficient test coverage before you do so. Okay, so configuration, how to configure linter. When you install it in a project, let's say ESLint JavaScript-based linter, you will install it with npm install linter, ESLint as a dev dependency. And then you will have config file that you can specify what rules you want to follow, which rules you want to skip. You can be following the ESLint recommended set of rules, or maybe depending on the project-specific framework, you want to use the rules defined for, let's say, React, Vue, or maybe your application is using TypeScript, so you want to use this set pre-configured good practices rules for this TypeScript. And the same when we talk about test framework, there are ESLint plugins for Jest, for Cypress, and for Playwright, as I was showing an example. Also, a few big engineering companies decided to open source their ESLint config, so you can use the same ESLint configuration as Airbnb, Google, or Shopify. I think it is a great initiative, but keep in mind that those set of rules are opinionated, so may not work for you. Okay, how to level up with your linter knowledge. So imagine in the organization there are multiple projects. And you just copy-paste the same ESLint configuration, because that one worked great for this project, so it would be good to enforce it in other repositories as well. Then you may think about maybe creating your own ESLint plugin. And ESLint docs give you guide how to do it, how to create your ESLint node module. You can either open source it in NPM registry, or maybe you can publish it to your private NPM registry for use for your organization only. You can also create the custom rules. So let's say that did you notice that in the code base there is this convention for the variable name underscore snake cases appearing in some places. And the JavaScript based test framework, so you want to enforce camel casing. You don't want to checking each PR. You don't want to fixing this after someone commits it to the repository. So you want to have this custom rule that will be checking for camel case convention in a variable name. And this is just an example. You can think about other rules that may work for you. Something you thought, oh, that will really save me lots of time of checking the pull requests. Maybe you want to prevent certain keyword appearing as a string in the code, or maybe you want to prevent the integer value to any place of the application to be less than 0. You can create your custom rule for it as well. And ESLint gives you example how to do it. So in the top code snippet, you can see basically rule being exported. The name is camel case convention. And we'll be checking that we're doing regex check on a node name. And if there will be issue, that the message will be thrown. Brilliant. And that's how you add it in the config. However, it wasn't clear for me at the beginning what this block of code actually does. That's why I decided to dive deeper into what how linter works under the hood. So there are a few concepts that linter actually using. So parsing, linter is using parser, the static code analysis, tokenize the value, and transfer it into abstract syntax tree. I will explain right now what it means. So we have a code input. So the block of code that linter checks. In our example, is the snake case variable name, my variable equals 42, semicolon. So first, linter splits this value into tokens. So const is separate token, my variable is separate token, equal symbol is separate token, 42 numeric literal is separate token, and the punctuator at the end, semicolon is separate tokens. So this line of code is actually 5 tokens. And there are different types of those tokens. So here are a few examples. But they could be keywords, so let, const, return, class, def. Identifiers, so variable names, function names, class names. Literals like string, numeric value, null, boolean, and so on. Operators, like in an example of this variable, equal symbol, punctuators, semicolons, bracelet, commas, and so on. But also white spaces and string escape sequences are separate tokens. So once we have input split into tokens, linter does parsing, parsing into abstract syntax tree, so the JSON representation of the code, and groups it by the node types. So our my variable is the type of variable declarator that has start position, end position, that has identifier as the name of my variable, and and numeric literal as the value of 42. And there are different types of the abstract syntax tree nodes. Like there are just few examples here, like expression statement, if statement, objects expression, class declaration, function expression, function declaration, string literal, numeric literal, and so on. Yes, so that's going back to our node is a variable declarator here. And just to remind ourselves example from the ESLint how to configure custom rule. I hope that now it makes more sense. So we basically get the context. We do checks on, verify the node name doesn't include the underscores and is camel cased. There are many different places in the application where the abstract syntax tree is actually used. So code coverage tools use it. The detectors for security or vulnerabilities also use the abstract syntax tree. Code generation tools, refactoring tools, IDEs, as I mentioned, some of them have already built in. Obviously, compilers and code formatters like Prettier also use it. One more thing before I finish. I wanted to share with you some tips. So first, if you will go to AST Explorer website, you can experiment yourself in like translating maybe more complex functions, classes into abstract syntax tree and see this JSON representation of the code much more complex than the example with variable. Go to ESLint docs. They will explain you how you can build your custom plugins, how you can deploy the NPM module, and how you can contribute and maybe learn more about how ESLint works. And for the purpose of this demo, I was using the script package to generate tokens and abstract syntax tree representation. It was simple as console logging the value from output from the method. So I would recommend to use an experiment with it as well. So yes, thank you for joining my Atomic talk. If you would have any questions, you can find me on a LinkedIn. Drop me the message. I'm more than happy to discuss anything. Have a good day. Thank you.
Hi, everyone, and welcome to my talk on building automated quality gates into your CI pipelines. A talk which I hope you'll find really useful to be able to ensure when you want to balance both the need to deliver software very quickly and the need to deliver high quality software, you'll be able to solve through utilizing this idea of automated quality gates to help you to balance both sides of that software delivery paradigm. But before I continue any further, a little bit about me. My name is Craig Reesey, and I am the head of engineering at Old Mutual. I also run my own board game company called Risky Games as well. I have a book out called Quality by Design, where you can get a lot more about different things around how you can design software with quality in mind from the beginning, along with me. If you're trying to figure out my accent, I'm from Cape Town, South Africa, and these are just some incredible sights from my beautiful city, which I hope you'll come visit one day if you've never been. But back to my topic on hand. What is a quality gate? And this might be a new sort of thing to some people. Some testers might refer to them as entry and exit criteria when it comes to the testing and what they need to do. But essentially, the big thing that we're trying to focus on with quality gates is trying to create some sort of change control or some sort of automated measure which can assess that the quality of the software is ready to be able to move on to the next phase. If we think about it from a CI/CD pipeline perspective, we each have steps in our CI/CD pipelines, and we want to make sure that the software is of a proper quality before we move it on to the next phase. And that's essentially what it does. The reason why we want to do this is because it prevents development from moving to the next stage, until certain measures are met, to make sure that whatever we're delivering meets our quality needs and that we're not delivering or deploying poor quality software somewhere that's then hamstringing other parts or other departments within our software development organization. So it's important to make sure that we can do it right and that it automated so it can fit the actual CI/CD strategy. Because again, we don't want to have quality gates that are now slowing us down. A lot of time people view process as something that is maybe slowing them down and they're hesitant to put quality gates in place. And that's why we need to find ways of making sure that these things are going to be automated so that it doesn't slow you down. It allows you to continue to move quickly and deliver. Why quality gates and why should we focus on quality gates? Well, I think it's first because it's a focus on something that is measurable. So when I say what's of high quality, it's often very difficult to determine what is high quality software and what is not. So what we're looking for with quality gates is something that is really measurable, something that we can look at from an acceptance criteria perspective, to make sure that everything is met and ensure that we have the right measures in place. Quality gates help drive a shift left mindset development. So in order to have proper quality gates in place, particularly when they're automated, we need to ensure that we're actually bringing the design and the testing of our software earlier in the phase. We're not now checking things at the end. We're checking things from the very beginning of our design of our software, of us writing code, implementing code. We're already starting to check, are we happy with the quality of the output? And by automating that, we're just safeguarding ourselves against poor quality code later on. That we're preventing making future mistakes or slowing us down as a team because we're putting the right quality gates in place. We're thereby also preventing testing from being impacted late in the cycle. The testers don't need to worry about that end of sprint crunch or that end of cycle crunch because everything's really starting to be tested early on. And it ensures that we have proactive quality, again, that we're not looking at quality in retrospect, but we're trying to design quality into the process of what it is that we're trying to deliver as an organization. But it's more than just having quality gates in place. I think there needs to be a lot of building blocks for quality gates before we can start doing this properly. And I think this is one of we first need to start with actually having well-defined and clear completion criteria. We need to know what measures are needed to say, this is what we need from a well-designed requirement. We need to have a testable architecture. Ultimately, in order for us to really automate our quality gates, we need to ensure that everything can be testable. And that means that specifically from the software we're designing, we should be able to write unit tests against every single component within that architecture. So we need to make sure that everything is testable, obviously with a strong focus on unit testing, again, with that shift left mindset, trying to ensure that we can bring everything into a unit test. And if we can put strong unit tests in place, it allows us to then be able to move it on to the next phase. We need to have strong automation teams in place with regards to integration tests. So it's not just about having strong unit tests, but now we pass it on to another phase where we're starting to do integration tests and maybe some bigger end-to-end tests. We need to have those in a way that can be automated. And then lastly, I guess along with the most important part being at the top with a well-defined and clear completion criteria, we also need to make sure that this, we have the right sort of idea behind this. If you're working on big iterative cycles where you want to deploy once every 6 months, once every 3 months, it's probably not a good idea to try and automate that process into a pipeline because those are really big, bulky releases that will require a lot more effort to be able to test properly. Really, where you want to use this type of strategy is when you're working on small, frequent releases where the change that's implemented is really small and that you can really accurately test that adequately within your automated test structure, and you're not having these long, complicated or big, complicated, long testing cycles that really don't fit well within a CI/CD structure. Again, we've got to think CI/CD as in fast deployment, fast integration. Therefore, we need to think of small, frequent releases and not these big release cycles. So you might not use it everywhere within your software delivery process, but focusing more on your small, frequent releases. And then what are some of the things that we want to check? So we understand what a quality gate is. We understand why we need them. But what are some of the things that we're actually trying to do with this? Well, I think we need to focus on things. And these are just some ideas of things that you can measure. There's obviously a lot more that we can do. But essentially what we're trying to do is we want to measure things like build health. Did our code build right? Infrastructure health. Is there infrastructure that we need to deploy into of a healthy state before we deploy into it? Have a look at test results. Probably the most obvious thing where we have a look at test results, but not just test results from an integration test, but making sure that our unit tests so that everything's okay with that. We then looking at things like our code coverage, not just that our tests pass, but was our code coverage sufficient enough to be able to justify us moving on to the next phase. We don't want to have 100% of our unit tests passing, but our code coverage is really only 50%, because essentially what we're saying is we're deploying half-ready software into the next phase for integration testing, rather make sure that our code coverage in our unit tests is quite high. That's a clear measurement that we can put in place. Our security scans, we want to have software that can run security scans and make sure that that's adequately scanning our software to prevent security defects from moving later on. Same with performance. We can measure performance at a code level very early on. As we're deploying our code, we know that our code executes a certain amount of time, and you can either have your unit test assessors, you can use tools like K6 that are very good at being able to measure performance within a pipeline, and use that to be able to assess your performance. And then lastly, something like incident and issue management, the number of defects we have, a lot of the issues that we're facing, the severity of the issues that we've logged, you can easily measure that and be able to build that into a system, be able to prevent software from moving on to the next phase or being deployed into production when there's a lot of incidents that are still open, and you can kind of prevent that from happening. And only once it gets to the point where you're happy with the incidents and the risk involved with the software release, will it then deploy adequately. Yeah, so those are some of the things that you'd want to look at, but what type of quality gates we're looking at. So obviously the different stages in the quality gate process would be things like your setup and checkout of your code. When you're actually building your code, you have a quality gate in place there. After we've built the code, we want to execute unit or CI tests. We put that there, and then we can go and check those things. We can do a static analysis scans, and that can be a separate quality gate. Environment readiness checks for when we want to deploy into an environment, make sure that things are ready before we deploy. Then we can do pre and post deployment checks on those environments. So before and after, once we deploy the software, we then want to also check to make sure that the environment is still operating and running. Then things like our integration test execution. So we now want to move on from our unit test into something that's now integration testing, and we want to go and check that against maybe a bigger environment against the rest of the functionality. We want to have a quality gate that can measure that. Our dynamic code analysis and things where we want to be able to make some adjustments within the code, whatever it might be, that's very important that you want to do. So there's sometimes some things that you want to do from a static analysis, but then there's also stuff that we can run from a dynamic code analysis that can really help us with this. And then we have non-functional test execution, looking at things like our security, like our performance or our load or our stress testing. We can actually go and run those checks and ensure that everything's in place within that build cycle. So these are all things that, if we think about it, we can actually measure the success of each step in these things, and we would have a quality gate around that. So as we're readying our software to get to a point where we want to deploy into production, automated or executed or run, that can give us results from these things. And so it's very important to be able to assess that properly. An example, just going on from the quality gates, are things like linting standards need to be met before the code can be built. Something like 100% completion of all your tests with 90% code coverage at a unit level, or 100% of across all of your code coverage once your scans are done, and a successful pass of all automated checks. Just some obvious examples of things that you would put into a quality gate to ensure that we've checked, we've measured this, we're happy that it's now ready to move on to the next phase. I'll put here a basic sort of CI/CD pipeline and how it would look. Yours might look different, and you would probably use different tools to be able to achieve the same thing. But here's just roughly how that would look, and there's certain things you'd want to do from start all the way to the end. You might not always have these in the right order. You might want to use some of the non-functional tech checks earlier. You may do your dynamic code analysis earlier, and you may deploy in different stages depending on whether you have a QA environment or a staging environment or other environments in between. But the point is that, again, at each of these steps, as you can see, it's very easy to be able to ensure that we can put checks in place to say we're happy with what it is that we've got here. And it is very important to be able to do this, and again, to have defined criteria for each step so that we then know, okay, well, when we're running this check, we can automate it, we can check the response, and we can determine from an automated perspective whether we're happy with the output or not. Another way of doing it, and this is now looking at something that goes pre the code and sometimes even analysis and development. So that last one was just looking at CI/CD, but it's even possible to sometimes look outside of things and put some checks in place from our documentation perspective, having a look at our monitoring from an operation perspective. Do we have the right monitoring in place? Does monitoring exist? Have we set up the monitors? If not, don't deploy the code. Putting our things like our mutation testing, making sure that we have that within our development cycle. And there's, again, different things that we look at, and there's different ways that we can move code around before it merges between the branches or moves on to the test bench to ensure that we are happy with the quality of what's been delivered. So these are actual things that we can check. Even at an analysis phase, we can check certain deliverables, we can check certain schemas, and certain things exist. We might not be able to read or assess it, quality of everything clearly, but we can check that they exist before we're moving on, and we can put, again, criteria in place that can measure that. I'm going to move on to the how to build quality gates now, and this is a very high level look at how you could perhaps do this in Azure, just utilizing some tools like Visual Studio Code, using Git to be able to then build an Azure ADO pipeline, and then be able to build those things. But I want to specifically focus more on perhaps something like this, where we're now having a look at code. And this is some example of some YAML files where we want to have a look at things before and after a deployment. We have a pre-deployment test and a post-deployment test. Where pre-deployment, we're got some bash jobs that are running, maybe calling some configuration within our server and database, and just making sure that we can do a health check and ensure that we're happy these things are up, and we can put a bash script in place that can put it together. Same with our post deployment. We can then have something where we're actually creating the smoke test folder. Now we want to create a bash script. It doesn't have to be a bash script. It can be an actual sort of test execution thing that's then going to check this, but we want to then go and check that everything is up and running post our deployment of something. We can measure our code coverage and pass rate. And this is, again, another example here where we're actually now utilizing a tool that runs the scan. In this particular case, it's Kobatura. It's running the scan, and then we're just making sure that it can analyze the results within a certain directory, and then it's got to make sure that the code coverage target in this case is 90%. So what we're saying here, and you can assess, I'm just looking at the code coverage target. You can break that down into the line coverage, statement coverage, how you want it. You can add multiple measures in place based on what it is that you want. And then you can also assess whether the pass rate is 100% or 95%. You can add a whole bunch of measures. All I'm looking at here is saying that the code coverage target needs to be a minimum of 90%. So it's got to scan and say that at least 90% of it is passed before it will move on and allow the deployment. But again, this is just an example of how you can build these measures in place and create the tasks within your pipeline that allow for that check. And here is another check where we can actually check for successful scan results. So here we're actually running an aqua scan against the code in this example, and we're actually now going in and assessing the results of that aqua scan and saying, well, if we have any critical issues, depending on what the severity is, here we've set it to being critical or high vulnerability, it won't let it continue. It's saying that you can't even build this code any further because there's a critical issue inside, and you need to deal with that and sort that out before it will then deploy further. And we can build this code into our pipelines and make it flow quite consistently. So again, something that we can do quite easily within our code if we have it right. And I wanted to end off on this last point just about observability, because at the end of the day, all that we're trying to do with these quality gates and the CI pipelines is really bring observability into the mix. So very important that as we're doing this, that we can collect data from multiple points, that we can bring all this information into something. So yes, we can have our CI/CD pipelines run all these things, but we also want to now take that information from our CI/CD pipelines and all the execution runs and actually see what's going on and have some observability to be able to analyze our process, because we need to adjust it from time to time. Our quality gates might meet our needs for now, but might not meet our needs for the future. And so we want to be able to analyze these things better, and by being able to take data and store data in a certain way and be able to visualize and set up alerting on your quality gate itself, so you can actually assess not just when your quality gate fails, but why it fails and is it meeting your purposes, and then maybe track trends of failures. It helps to then better refine your quality gate to become something that is more adaptable for you. Thank you so much for your time. Hope you enjoyed the talk.
Hello, everybody. I'm Harpreet. I'm the co-CEO, co-founder of Launchable. We use AI, machine learning, to help software and QA teams We've been named as the best AI tool for developers at the AI Breakthrough Awards in 2023. We are an AI co-pilot for triaging, understanding, and managing test failures. First, we were founded by myself and Kosuke, who's the creator of Jenkins. And our central premise was that we wanted to use data and AI to help engineering teams improve developer experience and software productivity. And our approach is language, test framework, and test stage agnostic. DevOps pipelines are lopsided. You try to go faster, and tests are the bottleneck in your delivery pipelines. So in that context, we focus on helping software and QA teams deliver faster. So if you think about it, once you have tests, every team drowns in a fire hose of test failures. Kind of go through these 5 stages. You run the tests, you get some failures, you filter away the noise, you analyze the problem, you raise awareness of the problem, and finally, you start tracking the fix as it comes along. Today, we help in 4 of these 5 stages, and our intent is to help in all 5. So let's go down through each of these stages and see what Launchable can do for you. So first, on the run side of the house, there's no point running all the tests all the time. So we use machine learning to predict what tests are likely to fail and help you to run them early to get feedback faster and cut execution times on your test runs. We can reduce your test execution times by up to 80%. Josh, would you like to demo how we do that?
Yeah, thanks, Harpreet. This is the launchable web app that you can see on the screen right now. And this data that's populated here comes directly from the launchable CLI, which records both build and test data from your CI pipeline. As you send data through the launchable CLI, a machine learning model is trained. This model will allow you to run subsets of tests based on targets of your choosing. You can find a confidence curve generated on this page. So I'm navigating on the left-hand side under Simulate. You can hover over the graph and find the confidence at various time intervals. Confidence is the ability for a subset to find a failing run. When you make a subset request, you would choose a target based on the data in this graph. Subsetting enables you to run only the most relevant tests based on recent commit data. This helps to speed up your CI/CD pipelines, as well as provides faster feedback to developers and QA engineers. Subsets can be used in a number of ways, but our most common are subsetting in place and shifting subsets left. By subsetting in place, you can reduce the amount of time it takes to run a test suite in your CI/CD pipeline. By shifting a subset left, you will request a subset of a test suite and run it further left than it currently does in your CI/CD pipeline. This allows developers and QA engineers to get much faster feedback on relevant tests to make sure their code is up to par. A common example is to add a subset of tests to the opening or merging of PRs. Back to you, Harpreet.
So we'll get to the next stage, which is filtering away issues. So we have a feature called Test Suite Insights, where we can help you filter flaky and unhealthy tests and more. The idea behind this is we can use data to find the impact of unhealthy tests on your productivity. You can bring this up front during your sprint planning and filter out tests that are not healthy and consequently improve your developer productivity and your general quality of your test suite. Back to you, Josh.
Great, thanks. So I'm pulling up the web app again. And this time, we're looking at the Insights section over here on the left-hand side of the web app, and I'm on the Trends page. There's 2 pages under that that we'll go over shortly. For trends, you'll see a number of characteristics that we're able to pull from the test data that we collect through the CLI. A lot of them are pretty straightforward, such as total duration, average duration, total number of test sessions, and test session failure ratio. In the top right corner, you can see some time intervals that you can select this by. And down here, you can see some graphs where the data is displayed easily for you. Moving on to the unhealthy test dashboard, along with those other characteristics, we pull out a number of trends that we see inside of the data that we collect. These are labeled into various sections inside of here. The first being flaky tests, the second being never failing tests, the third longest test, and last is the most failed test. Scrolling back up to flaky test, we're able to actually remove these flaky tests from subset runs through a command line option. You'll see here there's a flakiness score in this column. Through that command line option, you can set the flakiness score to a number such as 0.8, and it would exclude every test above that as far as the flakiness score is concerned. For flaky tests, this sort of information is invaluable to QA engineers as they can help to resolve tests and improve their overall test suite quality. Back to you, Harpreet.
So once you have filtered some tests away, and you can, the next thing that people tend to do is to go figure out, like, what is this problem about, right? You're going through stack traces and stack traces, and often you find that, some stack traces are the same, but you're still spending time going through it. Then the next question that you tend to ask yourself is, are these issues the same? Are these failures the same underlying issue, or they are different issues? So the next thing that we are about to announce in a month is intelligent test failure diagnostics. Out here, you use generative AI to quickly understand issues and classify these issues for faster root cause analysis, right? So imagine a place where instead of going through stack traces, you see a one-line description of what this stack trace is about, so you can quickly comprehend this. The next thing you can do is you can look at, say, 500 of these issues and say, these 500 issues, Launchable is telling me are the same underlying, these 500 test failures are the same underlying issues. And we can classify that and triage one issue at a time. So that's what is coming up. And stay tuned for more announcements here. The next thing that we do, and I'll move on, is we help you sort of make developers aware of what the problems are. So in this case, the idea here is you have test failures, and developers have to go, and QA have to go somewhere to find out what the test status is. Instead of that, they can react to failures quickly, where personalized push notifications are coming into them, and then they can jump off from there directly to the issues and help find those problems. Josh, over to you.
Great, thanks. So we're going to jump back into the web app. And this is our main test sessions page. From this page, you can click on this link right here for any test session to dive into specific details and look at failed tests from each test session run. You'll see here that the login test was executed twice, and it failed both times. This is now labeled as a top longest test and a top flaky test, which are categories from the insights page that I reviewed earlier. Using the Slack notifications, we're able to transmit this data about these failed tests in each test session directly back to developers and QA engineers through Slack, so they can get this information as fast as possible without having to go through anything in between. Back to you, Harpreet.
Great. And the idea there is that if I was a developer or a QA person and I saw a failure and I saw a top flaky test there, it's unlikely that, the recent commits have made the change, made this failure possible. So I'm able to jump ahead and not worry about it. If on the other hand, this test had never failed, that's something that I need to look at. That's the end of our demo. I welcome you to come to launchableinc.com.
Do you know the feeling when you are not sure what is happening with your tests, who's accountable, and where things stand? Hi, my name is Natalie, and I'm on the Practitest team. Practitest is an end-to-end test management tool where you and your team can document, track, control, and manage your manual and automated tests in